we will talk mostly about equity and FX options. Equity options are options on equities. FX options are basically options on forex exchange, which means that they give you a right to sell one currency versus another. In a world of options, it's actually almost doesn't matter what is the underlying. It gives you some details, some specifics, but big picture is the same. So we will work with both of those two, FX and equities. Let's write it down. So those options are traded on the exchange, as I said. It means that usually there are several terms and bunch of strikes you can trade. They're predetermined. The first task of the project will be to get the data and to construct the volatility surface. I presume that not everyone knows what the volatility surface, but basically, if you take it another way, it's kind of graphical representation of prices of options, but prices not in dollars or like euros or other currency, in some metrics, right? So usually price metrics are in dollars. Say you buy in gold, you're buying it for some amount of dollars per some weight, ounce, or maybe a kilogram or whatever. Some metrics are not in price. They can be not sure what to say, how to say it, but basically, say it's some condensed metric of price means that it's not in dollars, but you can convert it in dollars if you know some other things. So that's what it condensed. It loses some information about other market, right? I think I want to try to tell it more simply, made it more hard. Anyway, so this is some kind of graphical representation of prices. It usually calls volatility smile because like 85% of time it looks something like this. So like a graph, right? It's easier to see some problems with it. On a graph, if you see graphically, like for example, if you see something like this, there is something for sure, something that needs your attention. All right. So a lot of people using this graphical representation of prices. We will construct this first. I think this is one of the most basic things you can do in options. On the one hand, on the other hand, when you go to the exchange, it's there are a lot of details, and as one say, deal is in the details. It is, you can apply it here. So, for example, the first thing we will think about is like, what is the price? What do you call the price, and why is it that? And so on and so on. So we'll go through everything from the basics. We will first make this volatility surface. This is the first part. The next part is that we'll price out of this volatility surface other options we have in our book, imaginary book, of course. So we'll generate a bunch of options, say 20,000, something like 10 to the power 4 or 5, depends on how good we are. And we will try to price them based on those prices we got from volatility surface. So big picture, what we are doing here, we see some options on the market. We extract some metric, which we will call prices, right? And we imagine that we have a lot of options that we already traded in the past on the same exchange, so the same options. And we will try to price them based on the prices of the options that are now on the market. By pricing, what I mean, we will get some metrics like price and Greeks. What are Greeks? Greeks are basically derivatives of the price with respect to some market metrics. Say the easiest one is, for example, if you price in option written on some stock, say Apple, right? So what you want to know is that if the stock goes up 1%, how much will price of the option change? It's not definitely, but it's very probable it will not change for 1%. It will change for some less amount. In some cases, it changes on more than 100%. We will take a look at all those cases. So there are a lot of Greeks. We will take a look on first, say, 6 of them, and we will calculate them for each option. How we will do all of this? We'll basically produce a code. It will be C++ or Rust. I would prefer it would be Rust, but we can do C++ depending on what the audience can do. And this code will produce all those outputs, so whole surface and Greeks. If you have more time, it depends on the overall velocity of the project. We will try to do something for market making world. So let's say we will try to calculate how much should we shift the price of the option in order for it to be traded with some expected probability. So say you have prices on the market which are can be graphically represented by some line, like here, right? If you have here a strike, so there will be some price here, right? And if you offer some option above it, if you offer it very high, the probability of this option to trade is nearly zero. It's basically only someone's mistake that would take this option. And if you price it right in the middle, the probability is quite high, actually. Say for the next 20, 30 seconds for trade to happen, it's almost definite it will happen. So the probability in this case will be a function of how good, let's say, how good you price the option according to the market. So we will try to estimate this in some cases for some options. To better understand how we should shift a price for it to trade with some certain probability in some amount of time.